binomial products. So as the name suggests, binomial, bi meaning two, nomial meaning, terms, polynomial, many terms, the same sort of thing. So a binomial product is when we multiply something with two terms times something else with two terms. You may remember all sorts of ways of doing this. Cross method, first, outside, inside, last. Of course, there's the face method. You know the face method? Watch and learn. Okay. It's just, see, I draw the line in. It really is the FOIL method. But first, x times x. Oh, that's x squared. Outside. Oh, x times 1, that's x. Inside. X times 6. Oh, that's 6x. And then the last ones. But look, you got a face. You see it? Do you see it? You got the chin. There's the mouth. There's the eyes. You got ears and a nose in the middle. It's a face. And then you know you've done it. And of course, in this case, we have to tidy up like terms, and there you go, 7x plus 6. So, binomial products. Now, we have some special ones, because maths is all about patterns. Right? Mathematicians will spend a really long time trying to find a quick way of doing something. In fact, sometimes we spend an inordinate amount of time. We could have done another way a lot quicker. But once we find that quick way, I can use it again and again and again and again. So it was worth spending the time finding the quick way. So a plus b squared, yes, I could do it as a plus b times a plus b, but we notice that every time we do it, we end up with that pattern, a squared plus 2ab plus b squared. So now, rather than doing the expansion, I know I'll just write it as a squared plus 2ab plus b squared. The minus one's very similar, it's minus 2ab, of course. And then to generalise that, I'm sure you knew this, to generalise that, if you had any of them squared, you're always going to get each term squared plus twice every possible product. Oh, we learned something. Excellent. Okay. That always works. Difference of two squares, a plus b, a minus b, or the other way, doesn't matter. Obviously we get a squared minus b squared. So, x plus 2 squared, I now don't waste time. I write down there. Now, of course, you don't write this down probably. You're probably thinking this, but we're saying, look at that. A plus b squared, yeah, that's the situation I've got. So a squared, that's the x. 2ab. So in my case, it's 2 times x times 2, and b squared, that's 2 squared. So in reality, we just write that down, x squared plus 4x plus 4. So 3x minus 4 squared then becomes 9x squared minus 24x plus 6. We save ourselves some time. So by discovering for want of a better word, a formula, we can save ourselves time down the track. Difference of two squares, 4p squared minus 25. This one's a binomial times a trinomial. And this is, I find, where drawing the lines in comes in handy, just to make sure you've got to multiply everything by everything. So, okay, I'm going to multiply everything by everything. I've got 2 terms in the first one, 3 terms. I know I should end up, before simplifying, with 6 terms. I'm expecting 6 terms. So if I don't get 6, I know I've forgotten to do one. So the answer has 6. So let's do it. Here we go. I'm going to do a times that. 8, right, yep. Now 2 times, bang. And so I've just drawn the lines in there. I know, yep, I've got everything covered. Then we see, does anything tidy up? Yes, it does. And there we go. We end up a cubed minus a squared plus a plus 14. However you choose to do it. But as I say, you just got to make sure every term is times every term. Have you ever seen the method of detached coefficients? Let me just show you this one. So if you want to multiply 2x cubed minus 4x squared minus 5 with 3x squared plus 4x minus 2, here's how we do it. We list all the coefficients of the first factor, starting with the highest power. So that's 2 minus 4. There is an x term in there, it just happens to have a coefficient of 0. So 0 minus 5. Okay. Then we list all the coefficients of the second factor, starting with the highest power. 3, 4, minus 2. Notice you don't, which you would normally think you're going to do, you don't line it up like a polynomial division. The x cubed doesn't go under the x cubed. You start with whatever the highest power is. Okay, multiply all of the first row by the first number in the second row, writing the first result under the first number. Huh? So multiply all of the first row by the first number in the second row. So 3 times 2 is 6. I write it under the first number. 3 times minus 4 is minus 12. Write it under the second number. 3 times 0 is 0. 3 times minus 5, and so on. Okay. Now, multiply all of the first row by the second number in the second row, writing the first result under the second number. So this time, I start under the second number. 4 times 2 is 8, and so on. And then you'll never guess what I'm about to do. I'm going to get the third one. Then we add all the columns. And there's your answer. It's just that the coefficients have been detached from the algebra. So to write the answer down, there is. Now, the highest power will be the highest power times the highest power. So I must start with x to the power of 5. So therefore the answer is 6x to the 5 minus 4x 4 minus 20x cubed minus 7x squared minus 20x plus 10. I mean, you are effectively still multiplying everything by everything, but it's just a systematic way of doing it. Let's try another one. A plus 2, a squared minus 3a plus 7. I'm writing the bigger one down first, the longer one. So 1 minus 3, 7, because of course multiplication you can do in any order. So I'll write that one down first. And then 1 and 2. So multiply the top row by 1. Multiply the top row by 2. Add down the columns. Now the highest power of this one will be a cubed. So we will start at a cubed. The answer is a cubed minus a squared plus a plus 14. Founded in a textbook, first published in, what year was it? 1860 something. But anyway. Oh, here you are. Let's have a look at this one. 3x to the 4 plus 2x cubed y plus 4xy cubed plus 2y to the 4 times 2x squared minus y squared. I can still do it. 3, 2, 0, 4, 2. You see, you've got to look at the terms. Yes, they're x's and y's, who cares? But the powers of x are still just going down by 1. Forget about the y's. Just look at the x's. So I don't have an x squared term there. So I put a naught for that one. And I'm going to multiply that by 2, 0, 1. Again, forget about the y's. X squared. Oh, there's no x term there. Down the columns. The question is, what is the highest? Well, it's going to be x to the 6. Oh, sorry, I haven't worked out the answer yet. There we go. X to the 6. How do I complete each term? I just go take 1 off the power. Notice every single one of those terms, the 2 powers add up to be 6. So I'm just going down. X to the 6, x to the 5. Oh, I need the powers to add up to 6. So the other one's y. X to the 4. Oh, I need them to add up to 6. So the other one's y squared. So you could still use it for something like that. So it's a very old method. All right, there's the second bit.